Assalamualaikum warahmatullahi wabarakatuh. My name is Al-Kawarizmi bin Willy. So I will present introduction, basic diagram, and disadvantages. So for introduction, manual fluid process control involve human operators adjusting valve, pumps, and other components to regulate fluid flow, pressure, and levels within a system. While this method is simple, cost effective, it relies heavily on human judgment, making it prone to errors and slow response times. So this is basic diagram. We can see here fluid in and fluid out, which is this control the flow of liquid into and out of the tank. So tanks function to store the fluid with a level indicator and high and low level indicator. This will check if the fluid is too high or too low. And for meter, it's display the current level of the tank. For the stop button is stopping the process. So the system monitor fluid level and it's ensure they stay within limit by controlling inflow and outflow. For disadvantages of fluid process control, we have two, which is human error and slow time response. Human error, manual control relies on human operators who may make mistakes in measurement, valve adjustment, or response times, leading to inefficiencies and inconsistencies in fluid flow, pressure, or level. Next is slow time response. Compared to automated system, manual control is slower in detecting and correcting a deviation, which can lead to process delay, wastage, or even system failure in critical application.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Hilmi Iskandar bin Saiful Bari. My number matric is CN23045. Today I want to present methodology part 1. So firstly, software setup. Software setup, install the LabVIEW community version in the Google or Chrome. Second, watch the tutorial on the LabVIEW setup on the YouTube channel. Second, develop the simulation in LabVIEW. First, create new project. In bracket, front panel and block diagram. Third, front panel GUI design. First, use the metric tank indicator for the water level. Second, add fuel inflow and outflow um, control. Third, set max tank for 100. For include the PNID symbol for the valve, controller, and transmitter. Third, block diagram in code block. First, insert loop for the continuous simulation. Second, add the metric control indicator and use compressor function for the water level. Hello, see me again for the methodology part 2. So the fourth, run the simulation. First, without the null function. First, observe tank level change to which the inflow or outflow. Check memory indicator behavior when the tank empty. Second, when the null function. Null to function. Modify the block diagram to reset level water is level water when tank is empty. For compare result with the and which and without null function. Lastly, data collection and analysis. Record the observation for both scenario. Second, illustrate process using the PINID symbol. Third, compare result and analysis accuracy. Last, prepare video demonstration of the lab view simulation.
Assalamualaikum warahmatullahi wabarakatuh and very good day. Today, I'm going to discuss about discussion from the record that we simulate the result. The process without null has occurred, which is to state the result more than or less than tank measure level. This shows the data from meter came out to be false data. As for adding the null function, the simulation changed from 0 to negative. This is also a Q error and false data, but the function can be at least resetting the result of water flow inside constant 0. As for the water flow outside, it's go negative meter. That's all for my discussion, and I will pass it to another presenter. Thank you very much.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Um, See you again. I want to present about the observation tank level process control which end without null function. The tank level control system sometimes display incorrect fuel level due to sensor drive or offset issue. Even when the tank was empty, the sensor still showed residual volume leading to inaccurate readings. This requires frequent manual recalibration to ensure the accuracy, making water level monitoring and process control efficient. By enabling In by enabling the null function, there's an offset error where the eliminated, ensuring the sensor display a true zero reading when the tank was empty. This improved the measurement accuracy, reduced the need for the manual recalibration, and enhanced overall system efficiency with more reliable automation and control. Water management become more effective.
Okay, next slide is when horizontal slider for fluid in is active while fluid out is inactive. Constant water inflow. The tank level is raised by the active fluid inside slider, which permit a constant flow of liquid into the tank. Number 2 is no outflow. When the fluid out function is not used, no liquid leave the tank, which cause fluid to build up. Number 3 is overflow possibilities. The tank may be overflow if the inflow is allowed to continue unchecked. Number 4 is system reaction. To avoid an overflow and preserve equilibrium, a control system may sound an alarm or halt the inflow. Okay, next is when horizontal slider for fluid out is inactive while fluid in is inactive mode. Number 1 is continuous water outflow. Liquid can continuously leave the tank thanks to the active fluid out slider. Number 2 is no inflow. The water level falls because no new liquid enter the tank while the fluid in function is deactivated. Number 3 is empty tank possibilities. The tank may eventually run out of fuel if the outflow keeps on without being replenished. Number 4 is system reaction. To keep the tank from drying up, a control mechanism may sound an alarm or shut off the outflow. Okay, lastly for conclusion, we use LabVIEW in this lab to successfully reassemble an open-loop fluid level control system. The experiment show how the water level in the tank affected by fluid intake and outflow, as well as how various control tactics affect the precision of measurement. We addressed a significant drawback of the original design by introducing a null function which made sure the meter accurately displayed 0 when the tank was empty. Result demonstrated that in the absence of null function, remaining number continued to exist long after the tank was drained, resulting in imprecise result. On the other hand, adding the null function increased the fluid level monitoring accuracy. The stability of the tank and the water level were also directly impacted by the analysis of the influence of different inflow and outflow rates. Thank you.